Okay, so good morning everyone. Today we are on the third part 3 of our lecture on fluid mechanics. And this time around we're going to talk about Bernoulli's principle. So what is Bernoulli's principle? So Bernoulli's principle tells us that uh, as a fluid moves through a region where its speed changes, the pressure in the fluid varies with these changes as well. And that variation is given by the following relationship according to Bernoulli. So according to Bernoulli, the speed of a fluid is inversely proportional with that of the fluid's pressure. And it also works vice versa. Okay? So what does it mean? What does it tell us? It tells us that when we have a small fluid velocity over here, we would get a large fluid pressure. And likewise, when we have a high fluid velocity, we would get high fluid pressure as well. So to illustrate that or to show that, let's look at the following example. Okay, so I have drawn here beforehand cross-section view of an airplane's wings. So we have here over here here's an airplane's wing foil viewed from sideways or cross-sectional view, and the white lines over here represents the flow of air above and below the aircraft's or the airplane's wings. So if you notice, airflow above and below is, as we would describe, laminar, meaning to say the same amount of air would flow over, above or below the wing, irregardless of the speed of the aircraft. Now, since the same amount of air would flow above and below, okay, so let's study how does how is Bernoulli's principle applied in this situation. So you'd notice on top of the wing, okay, because of the airplane's wing shape, air has to travel a longer distance above than that of below the aircraft. Okay, so above, air has to travel a longer distance. Below, it travels just a shorter distance, as you would see. So what does it do? What does it do? What does it mean? So it means to say that above the aircraft, since the same amount of wind flows over and below it, it tells us that the wind must flow faster or must be moving above the aircraft's wings at a higher velocity. The velocity above, okay, the velocity on top is greater as compared to the velocity of the wind at the bottom of the aircraft. Okay, as we would see, you have higher velocity on top. At the bottom of the wings, you would have low velocity. So what does it tell us? What does this tell us? Since we know that, according to Bernoulli's principle, that the velocity, according to Bernoulli's principle, we have there the velocity is inversely proportional with the pressure. So at the top, we could say that since we have there a high velocity at the top, the pressure on the top is small. And likewise, the bottom, whenever small velocity, okay, it would give us a higher fluid pressure. Now, this difference in pressure at the top and at the bottom of the aircraft provides the lift needed to lift the aircraft. Now, as we all know, the higher the pressure, the greater the push. Now, since we have here, let me choose a different color. Okay. Now, since we have a higher pressure below, okay, this is the pressure below, as compared on top of the aircraft, it provides the lift needed to push our plane or to lift our plane up above the ground and enable it to fly. So that is Bernoulli's equation in action, or equation Bernoulli's principle, in action. So that's it. So I hope you have a clear understanding of Bernoulli's principle from this situation. Okay, thank you and goodbye.